Today we're going to be talking about the derivatives of exponential and logarithmic functions. So the formulas for derivatives of exponential functions, so if you have something that's not base e, so if you have a number there to a power, it's that thing, so the number to the power times the ln of the base times by the derivative of the exponent. Now this is the same thing, just I don't write the ln of e because the ln of e equals 1. Derivatives of log functions. That's 1 over u du dx for the ln of u. And then if you have a base there, it's 1 over u ln of a, and then the derivative of whatever, I call that the inside of the logarithm. Remember that ln of e is equal to 1, so that's why back here we have no ln of e. Okay, finding the derivative of each one of these. Now, finding the derivative, sometimes you want to use your log rules to simplify this. If you have the inside piece of the logarithm, where you can bring down the 2, now that's a much easier derivative. My derivative now is just 2 over x, because the derivative of ln of x is 1 over x. Here I would have to do the chain rule. I'd have to do, so if I didn't do that simplification, we'd have 1 over x squared times by the derivative of the inside, which is 2x, and then you'd simplify to that. So try and make your life easier. Remember my motto, work smarter, not harder. But now for number 2, really what this means, it means the ln of x squared. So I can't use that same trick. You can only use the trick if your exponent if the inside piece has that power. So now it is your chain rule. Bring down the 2 times by ln of x times by the derivative of ln of x, which is 1 over x, and just simplifying that out a little bit is that. Now our logarithms. Here we have a product rule. So derivative of the first is 1, leaving the second alone, plus leaving the first alone, derivative of log base 2 of x is 1 over x ln 2. And this, I should have my notation on there that that's my derivative. So really we have log base 2 of x plus x. Ooh, my x's cancel. Sorry, I didn't realize that until I just tried to simplify it. I was a little too excited about that. Now here, I recommend you rewrite this one as x squared minus 4 to the 1/2 power. Bring the 1/2 down in front. I'm not taking the derivative yet. Since I have a logarithm that has a power, I can bring that down in front. And now we can take our derivative. Log base 5 of something is 1 over the something times the ln. Ooh, I always write that funny. Times by the derivative of the something, so our chain rule. Simplifying that out a little bit, the 2 and the 1/2 cancel. And notice how I'm putting that x squared minus 4 all in parentheses. Okay, now derivatives of some exponentials. I always like e to the x because my derivative is simple. It's just e to the x times by the derivative of the exponent, which is that. Again, I'm okay with you leaving it like that. If you really want to simplify, just make sure you simplify correctly. And again, in calculus, it's okay if we have radicals in the denominator. Now here with number 6, ln of e to the x, that can come down and come in front. This becomes a 1, so our derivative is just 2x, making our life really easy. This is one I always want you guys to know. Sometimes it shows up on the AP. I would say a lot in multiple choice. I don't think I've ever seen it as a free response, but don't quote me on that. I'll say 87% sure. So could potentially show up on a multiple choice question. So I want to or on a free response question. So this is easy. Well, I think it's easy. I apologize. If you don't think it's easy, I shouldn't say that. So derivative. So it's just y prime is the derivative of that. It's just the function ln of 5 times by the derivative of the exponent. So that's 2x minus 3. So it's just the exponential ln of the base. And then don't forget your chain rule, derivative of the exponent. Okay, finding the derivative and state the domain of f of the derivative. So my derivative is this. So 1 over 3x minus 5 times by the derivative of the inside, which is 3. So that simplifies to this. Now the challenging part of this is you have to remember that your domain restriction comes off of what's originally in this function. So I can only take the derivative of numbers that exist in my original function. Remember, ln has an asymptote. The inside piece of the logarithm has to be greater than 0. So your domain of your derivative, it's the domain restriction that we have there, 5/3. And if you think about it, yeah, that's when you have an asymptote, but you can't think of the negatives because those negative values, say if I plugged in -2, that wouldn't make the original function possible. Okay, logarithmic differentiation. We use this when we have a variable in both the base and the power. So I have a variable here and in my power. So what you do is you take the ln of both sides. The reason we do that is that then enables us to bring down the exponent. Now, derivative of the left side is going to be an implicit differentiation, 1 over y dy dx. Here we have a product rule, derivative of the first, leaving the second alone, plus leaving the first alone, derivative of the second. Yeah, I screwed that up. There we go. I got too excited. I wanted to take the derivative. So 1 over inside times by the derivative of the inside. So now, simplifying that a little bit, now we need to solve for dy dx. So I multiply both sides by y. So dy dx is equal to this whole function times by y, but y is this original function here. Okay, our last example. We can use logarithmic differentiation if this right side function is a little bit crazy. And if I take the ln of both sides, remember that allows me to say that this is the ln of x squared minus 1 to the 1/3 power. I can bring that power down in front and then just even actually expand that more. Expanding this when you're dividing would be x squared minus 1 minus ln of x squared plus 1. So now do your derivative. Chain rule. 1 over y. You can also write dy dx as y prime. Derivative of this. I'm going to distribute the 1/3 through. Derivative of that is 1 over x squared minus 1 times by the derivative of the inside x squared, or 2x. Distributing the 1/3 to both terms. 1 over the inside times by the derivative of the inside. So y prime is equal to 2x over 3 times x squared minus 1 minus 2x over 3 times the quantity x squared plus 1. Now I didn't forget about my y. Remember, we multiply both sides by that y. But now you have to plug in what that y equaled. And y was this crazy function, the cube root of my craziness. And there is your answer. Please make sure your lesson summary is submitted on time.